In this video, we're going to take a closer look at the sine function. So I want you to imagine a frog named Freddy riding around on a water wheel at a mini putt golf course. This will represent the water wheel. This is the water here. And Freddy's going to start right here at a water level. And we're going to record Freddy's height as he's riding this water wheel. And as we do, we're going to fill in this table. So the independent variable in this case will be the angle through which Freddy rotates. And I'll use X to represent the angle, and the angle will be in degrees. And then the dependent variable will be Freddy's vertical distance or height. And I'll use Y to represent the vertical distance. And the units can be anything, but I'll just for now use meters. Now the radius of this water wheel is 1. Okay, so keep that in mind. The radius of the water wheel is 1. So Freddy starts at the water level, and he hasn't rotated through any angles, so starting at an angle of 0. If he's at the water level, he's going to be at a vertical distance of 0 from the water. Okay. If he rotates and ends up over here, okay, he would have rotated through a 90-degree angle, and now he's going to be 1 meter above the water since the radius of the water wheel is 1. Okay, and since it's above the water, we're going to use a positive 1 for the vertical distance. Then he's going to continue rotating and end up over here. Now he has rotated a total of 180 degrees. And he ends up back at the water level, so at a distance of 0. Okay. If he continues, the next point he will stop at is over here, which would represent an angle of rotation of 270 degrees. Now he's going to be 1 meter below the water. So since it's below the water level there, we're going to use -1 to represent it. Okay, and then once he's done 1 full revolution or has rotated 360 degrees, he ends up being back at the surface of the water. So his vertical distance would be 0. Okay, now if we graph this with Y on the vertical and X on the horizontal, here's what we're going to get. Just going to quickly scale the axes. Now I'm ready to plot the points. So here, first point is 0, 0. The next one is 91. And then next point is 180 and 0. Then 270 and -1. And then the final point is 360 and 0. And then if I draw a smooth curve for those points, I get this graph. And this graph is the sine function, y equals sine of x. Okay? And the reason it's called the sine function is because you can obtain Freddy's height above or below the water at any point using the sine primary trig ratio. So if this is the radius here, and we're interested in the height, the vertical distance here, which will be denoted by y, and we know the angle through which he rotated, we can use the primary trig ratio sine because y is our opposite side and r is our hypotenuse. So sine of the angle, and I'm going to change the angle to x here, is opposite over the hypotenuse. And our opposite side is y, and our hypotenuse is r. But r in this case is equal to 1. The radius is 1. So I have y over 1, or just y. So the equation that represents Freddy's height would be y equals sine of x. Okay? You can come up with these values here simply by taking these angles and plugging in them into this equation for x. So sine of 0 on your calculator would give you 0. Sine of 90 would give you 1. Sine of 180, 0. 270, -1. And 360, 0. Now let's look at some of the properties Okay, we notice that this is the cycle, one revolution, and the length of the cycle or the period is 360 degrees. Okay, the axis of the curve is going to be the x-axis here, which has the equation y is equal to 0. And because 0 is halfway between a maximum value of 1 and a minimum value of -1. The amplitude is the distance from the axis of the curve to the maximum. So in this case, the amplitude is 1 unit. Okay. The domain, this is a periodic function. If Freddy keeps going round and round, the domain in this case would simply be x belongs to the real number set. Okay. The range can be found from the maximum and minimum values, which are -1 and 1. So y belongs to the real number set such that -1 is less than or equal to 1, which is less than or equal to +1. So Freddy is going to move through heights of -1, which represents 1 meter below the water, and +1, which represents 1 meter above the water. Okay. Then if you note the x-intercepts are zeros, they occur every 180 degrees, okay, starting at 0. And the y-intercept is going to be 0 here. So these are some of the properties of the sine function. This is the parent sine function. This is the very basic sine function that you can have.